Hello everyone, I hope we all are keeping well and preparing for our upcoming examination. As we are taking the revision of 11th class NCERT and the chapter that we selected in the last video, because it was lengthy and one of the difficult topics in climatology, so we have divided it. We have already learned what is the air pressure and circulation and how we interrelate atmospheric circulation and air pressure in cause and effect relationship to each other. Now the same chapter we are taking a step forward. Today we will be learning air masses, frontogenesis, these terms are mentioned in our NCERT, and also the weather mechanism related to extratropical cyclone. And I will conclude this video talking about thunderstorms and tornadoes. So we are learning this chapter as our part 2. It is now circulation leading to different types of weather mechanism. We are getting to the study of weather mechanism causing precipitation one by one. Quickly reminding what we learned in the last video so that we can proceed further to understand weather systems. We learned planetary circulation. Planetary circulation is characterized with tricellular movement. The three cells that we learned included Hadley cell, Ferrel cell and polar cell. And it also gave us the reminder of the height of tropopause that varies from low latitude to high latitude. And it is with these three cells that we learned three types of planetary winds: trade winds, the low latitudinal, westerlies, the mid latitudinal, and polar winds, the high latitudinal wind. Let us start with air masses. The air masses from our NCERT. When the air remains over the homogeneous area for sufficiently longer time, it acquires the characteristics of that area. The homogeneous region can be vast ocean surface or vast plain. The air with the distinctive characteristics in terms of its temperature and humidity is called air mass. So let us define air mass as: air mass is three-dimensional homogeneous masses of air. How do I characterize air masses? Homogeneous masses of air, and homogeneity is measured in perspective of two things. Which are they? Temperature and humidity. Remind yourself, both temperature and humidity is principally sourced from Earth's surface. It is therefore the homogeneous surfaces over which the air masses formed are called source region. So what will be the source region? Source region is surface of the earth. Surface of the earth which is homogeneous enough in terms of its temperature, in terms of its humidity, can develop air masses. So source region or surface area can be of variable types, and that is where our NCERT reads: the air masses are classified according to the source area. Warm tropical, subtropical oceans, subtropical hot desert, relatively cold higher latitudinal ocean, very cold snow covered continents in higher latitude, permanently ice covered continents in Arctic and Antarctica. Accordingly, how many types of air masses we outline? The air masses outlined are maritime tropical, M, maritime, T, tropical; continental tropical, C and T; maritime polar, M and P; continental polar, C and P; and continental Arctic, star mark, continental Arctic. If you try to see these, if I say maritime is common here, so the characteristics will be wet for them. And continental is common here, so they will be dry. Remind yourself, what are air masses? Air masses are three-dimensional homogeneous masses of air, and homogeneity is measured in terms of temperature and humidity. So if I am air mass which is maritime, so I will be wet, and if I am continental air mass, I will be dry. But if I am continental tropical or maritime tropical air mass, let me encircle them together. So it will be warm. And if it is polar air masses, it will be cold. So what is maritime tropical air mass? Warm and moist. What is maritime polar air mass? Cold and moist, in that continuity. And then continental Arctic, as it reads here, it is the permanently ice covered continents in Arctic and Antarctic. Let us take support of this diagram. On this map of world can be easily notice the air masses demarcated. I am highlighting equator, and the air mass here is called maritime equatorial. I am at 30 degrees latitude on continents, landmass of Asia, landmass of Africa, United States of America. Which type of air masses are there? Continental tropical, but the neighboring water, Pacific Ocean, Atlantic Ocean, Gulf of Mexico, Caribbean Sea. Which type of air masses will be seen here? It is maritime tropical. Then I go near 60th parallel. Which air mass I will be seeing in Canada? Continental polar. Which type of air masses in northern Siberia and Europe? Continental polar. And neighboring Atlantic Pacific, maritime polar air masses. And then I can see in Greenland, continent Arctic. So air masses have got their defined source areas. Where do I see continental tropical air mass? In tropical land masses. So where will be maritime tropical air mass? In tropical water bodies. Similarly, where will be continental polar air mass? In high latitudinal land mass. And where will be maritime polar? In the water bodies of the higher latitude. We have just talked about source area. If we just try to recall what we have learned with our monsoonal mechanism of Indian weather, will it not be correct for us to say India during summers develops low pressure? Thus, maritime tropical air mass in the influence of southwest monsoons reaches the land causing rain. However, during winters, India is high pressure zone and thus it remains in the influence of continental tropical air mass with offshore winds and thus is dry. So basically air masses are those three-dimensional masses of air that tends to move in relation to each other in the influence of planetary winds, and that tends to create the weather effectivity. See this diagram? Maritime polar air mass southern hemisphere, maritime polar air mass northern hemisphere. Remind yourself this maritime polar that I have shaded stands synonym to Icelandic low. This is Aleutian low. This maritime tropical, shading it with dots, relates to Hawaiian high and Azores high. Which type of air mass will be in Canada? Continental polar. In USA, continental tropical. In northern Eurasia, continental polar. And in Africa and continental Asia, continental tropical. So whenever you talk about air masses, you need to talk about their source area. What are source area? Source area is Earth's surface from where the air column attains its temperature and humidity, sufficiently distinguishing it from the other neighboring air masses. NCERT fronts. When two different air masses meet, the boundary zone between them is called front. Why the two air masses will meet? Because air masses tends to advect in influence of planetary winds. And remind yourself, I have given you that planetary winds are three prominent types: trade, westerlies and polar winds. The process of formation of front is known as frontogenesis. Now what exactly is the front? Front basically is a buffer zone. Front is a transitional zone which is developed between the two contrasting air column. Now if you try to recall that we do have got intertropical convergence zone. Will we be developing in ITCZ? Will there be the development of front? Essentially no. Reason, it is convergence of trade winds only, and trades will not be having much difference in their characteristics or much difference in their temperature or humidity variations. That is the reason we don't develop front in ITCZ. Where do we develop front? We largely develop front at mid latitude. So mid latitude where we are subpolar low, where westerlies and polar winds tends to converge with each other. Reading it from NCERT now, there are 4 types of front called cold, warm, stationary and occluded. Brief definition is also given. When the front remains stationary, it is called stationary front. When the cold air moves towards the warm air mass, the contact zone is called as cold front. Whereas if warm air mass moves towards cold air mass, the contact zone will be called warm front. If an air mass is fully lifted above the surface, it develops occluded front. We'll just learn these types one by one. The fronts occurs in mid latitude and are characterized by steep gradient in temperature and pressure. Why it do not develop in low latitude? It do not develop in low latitude because we don't have that much of the contrast between the converging air masses. They bring abrupt changes in temperature and causes precipitation with formation of clouds. Now I have understood that there are 4 types of fronts. I have understood that these fronts are developed when the air masses converges with each other. But what exactly is the characteristics of each of these types of front? We can learn it with the diagram and then we'll come back to NCERT one more time. The 4 types of front mentioned in NCERT. The cold front. Cold front is developed when cold air mass tends to intrude into warmer area. Mind it that cold is intruding into warmer and warm will always be uplifted. It is comparatively steeper gradient. Warm front in comparison is where warm front tends to move and develops comparatively gentler gradient. Stationary front is identified to be the front where we don't have much of the movement of the front, because if you see the first 2 diagram, this is the movement of the front that is being shown here. How the front moves, we are just learning it with extratropical cyclone. So cold front is characterized with intrusion of colder air. So it is which air that is active? It is cold. Warm front, it is warm air mass that is active. If I say stationary front, there is no movement involved. That is the reason we call it stationary front. And what is occluded front? You can easily see that occluded front is the front where air column is warm, has lost its ground contact. Front movement is there again. Occluded. Occluded is characterized with decay of the front, beginning of decay of front. How do front develops? Front develops when air masses converges with each other. How many types of fronts can be there? 4 types. Stationary, warm, cold and occluded. NCERT, extratropical cyclone. The systems developing in mid and high latitude beyond the tropics are called mid-latitude or extratropical cyclone. Statement 1. Number 2. The passage of front causes abrupt changes in weather conditions over the area of mid and high latitude. Number 3. Extratropical cyclone forms along the polar front. Remind yourself, what was the development of polar front? Polar front was developed when, this is my polar front. Polar front was developed when cold polar winds and warm westerlies converge with each other. So say I am in northern hemisphere, southwest westerlies converge with northeast polar wind and it developed the front here. So please try to match it up with air masses. Can I say I can have continental polar or maritime polar air mass from here, continental tropical and maritime tropical air mass from here. So there will be the development of front. Number 4 statement. Initially the front is stationary. In the northern hemisphere, the warm air blows from south. I have already shown you this. And cold air blows from north. I have already told you this. When the pressure drops along the front, the warm air moves northward and cold air moves southward, setting in the motion. What is this setting in the motion? Carefully see this with our figure of NCERT itself. Cold air have started intruding into warm and warm have started intruding into cold. So if I take the direction of the motion of the center, what exactly is happening? First the air column converged. I am using double arrow to demarcate warm. This is my warm air. Warm air start moving towards colder region and cold air starts intruding towards warmer region. And which type of circulation thus starts evolving? The circulation that thus starts evolving is counterclockwise, developing what is called cyclonic circulation. I want to read it again. When the pressure drops along the front, the warm air moves northward and the cold air moves south, setting in motion, anti-clockwise circulation. The cyclonic circulation leads to well-developed extratropical cyclone with a warm front and cold front. Our NCERT also gives us the diagram, if you can see it. Warm air intruding into cold, developing warm front. Warm front is always shown with smoother curve in weather map. Reason, warm will be gradually rising up. There is no hurry or rush that you will notice here. In comparison, the cold front is where cold is pushing up warm. So if I am using bolder arrow for warm, warm is being pushed up, and that is the reason cold front is comparatively steeper in its gradient. So it will have more intense weather compared to the calm weather. Precipitation will be applicable to both of them. So what is the development of front? If I draw the diagram like this, to begin with, cold air from north and warm air from south converges. As the pressure drops, the warm air starts moving towards north and cold air towards south. So what happens? There is the beginning of cyclonic circulation, which will have counterclockwise movement or anti-clockwise movement, as is written in our NCERT. So this will be warm front and this will be cold front. See this image? Here we have direction of frontal movement. So front is moving like this. And can you recognize the map symbol for cold front? I have already told you. Advancing cold air behind cold front. So this is my cold front and receding warm air ahead of cold front. And because there is abrupt rise, which type of clouds we largely develop here? We largely develop vertically grown clouds that are cumulus cloud or cumulonimbus clouds. So I do develop the cold front weather is a significantly intense weather. And if I take the side view which is visible in this diagram, notice this is vertically grown cloud, as I said, cumulus or cumulonimbus, cold air, cold front. This is what is the top view. And this is my warm front with the gradual rise and thereby lighter precipitation, multi-altitudinal clouds. See warm front, don't miss to see the low pressure at the center. So we are taking the side views. Cold front looks like this and warm front looks like this. The cyclonic circulation leads to well developed extratropical cyclone with warm and cold front. There are pockets of warm air or warm sector wedged between the forward and rear cold and cold sector. Understand it? Very simple line. If I draw the diagram of my cyclonic circulation one more time and say this is my warm front and this is my cold front, and what will be this area called? Here we have got warm air in ground contact, so we call it warm sector. In all this area will have cold air. So read it. There are pockets of warm air or warm sector wedged between the forward and rear of cold air or cold sector. Forward and rear, warm sector. The warm air glides over cold air and the sequence of clouds appears. As the warm front is developed, warm air is rising over the cold air and sequence of cloud will develop, leading to the development of multi-altitudinal clouds and larger area of precipitation. The sky ahead of warm front and causes precipitation. Compared to it, the cold front approaches the warm air from behind and pushes the warm air up, because it is coming from behind and it is pushing the warm air up. So which type of cloud will develop? Thundering clouds. And what will be the precipitation zone? Comparatively smaller with intense weather. As a result, cumulus cloud developed along cold front. The cold front, very important statement highlighting it, the cold front moves faster than warm front and ultimately overtakes it. The warm air is completely lifted up and the front is occluded and cyclone dissipate. So what is occluded front? See carefully, warm front, cold front. Occluded front is right here, where the warm air have lost the ground. The process of wind circulation both at surface and aloft are closely interlinked. The extratropical cyclone differs from tropical cyclones in number of ways. We will be talking about it in details. Let us quickly take the support of this diagram. When the two air column converges with each other, they develop stationary front. Cold front is developed when cold air mass pushes the warm air up and develops vertically grown cloud with intense conditions. The front called warm front is where warm air gradually marches over cold and develops multi-altitudinal cloud with less intense weather. And when the warm air mass loses the ground, it develops occluded front. So extratropical cyclone is always related to fronts. And what is front? Fronts are the area of convergence of the different air masses. Difference number one is wave cyclone or temperate cyclone is always with front, and which is not present in tropical cyclone. Difference number two, they cover larger area and can originate over land and sea. So they are larger in size and can develop over both land and sea. I have taken a video that is talking about tropical cyclones in Indian context. Tropical cyclones die after landfall and tropical cyclone is comparatively smaller in their size. So this is the comparison. I am reading it from NCERT, whereas tropical cyclone originate only over sea and on reaching land they dissipate. Difference number next. The extratropical cyclone affects much larger area as compared to tropical cyclone. We have taken this. The wind velocity in tropical cyclone is much higher. It is less intense system. The extratropical cyclone moves west to east, but tropical cyclone moves east to west. movement is also different. Why? Extratropical cyclone is in westerlies belt. Tropical cyclone will be in trade wind belt. So I am reading this statement again. The extratropical cyclone moves from west to east, westerlies, but the tropical cyclones moves from east to west, trade winds. Thunderstorms and tornado. The other local storms are thunderstorms and tornado. They are of short duration, occurring over small area, but are violent. So we want to learn each one of them one by one, concentrating on thunderstorm from NCERT. Thunderstorms are caused by intense convection on moist, hot days. A thunderstorm is well-grown cumulonimbus cloud producing thunder and lightning. When the cloud extends to the height where sub-zero temperature prevails, hails are formed and they come down as hailstorms. If there is insufficient moisture, a thunderstorm can generate dust storms also. Dust storms, which we learned in the last video as dust devils as well. A thunderstorm is characterized by intense updraft of rising warm air, which can cause cloud to grow bigger and rise in greater height. This causes precipitation. Later, the downdraft bring down the earth cool air and rain. From the severe thunderstorm, sometimes spiral wind descends and that develops tornado. This part we are keeping aside. Now I'll come back to these underlined statements after reading the details with this diagram. When warm surface warms up the air and air starts rising, rising warm moist air tends to generate adiabatic cooling and condenses. Condensation develops cumulus cloud. Don't miss to see this 0 degrees Celsius temperature marked up in the diagram. If this cumulus cloud grows beyond the freezing temperature zone, then it can develop its maturity. That is, a cumulus cloud tends to grow to become a cumulonimbus cloud. In this cumulonimbus cloud, we can develop what is called hailstorm also. So I start experiencing heavy precipitation, which can be combined with hail as well. Eventually, when the moisture is sufficiently shed, the cloud starts dissipating, and this is how the system comes to an end with light rains. Three defined stages of the development of thunderstorms. Reading it again. Thunderstorms are caused by intense convection on moist hot days. A thunderstorm is a well-grown cumulonimbus cloud producing thunder and lightning. When the cloud extends to the height where sub-zero temperature is there can be hail. If there is insufficient moisture, the thunderstorm can generate dust storms. The thunderstorm is characterized by intense updraft of rising warm air, which causes cloud to grow bigger and rise to greater height. Cumulonimbus cloud. Stage number 2. This causes precipitation. So stage number 2, we have got heavy precipitation. And when the sufficient amount of moisture will be shed, automatically stage number 3, that is the dying stage or decay stage, will mark up its development. Now I want to read from where we demarcated the boundary. From severe thunderstorms, sometimes spiraling wind descends like a trunk of elephant with great force, with very low pressure at the center, causing massive destruction on its way. Such a phenomena is called tornado. To understand this statement, see this. I hope we are noticing it's a typically developed cumulonimbus cloud. Yes. And in this cumulonimbus cloud, I am noticing downdraft, which can cause hail. A mesocyclone is written because it is substantially big in height. And then we have got the anvil top, which do develops this overshooting top. Another term that is written here is virga. Virga basically is the rain that evaporates before it reaches the ground, and we do have rain here. So rain and hail all is happening. Which type of system we are talking about here? It's a typical example of thunderstorm. If in this thunderstorm there is the development of this funnel which touches the ground, this is called tornado. Every thunderstorm do not develop tornado, but tornadoes relates to thunderstorm. How does that develops? Let us try to see this. The first stage of tornado's life cycle is this funnel cloud getting developed from the lower atmospheric layer, and we have got warm wind, the dust that is warming up and is rising with the circulatory motion. This results in, because this is a supportive factor, so this results in funnel touching the ground. And do remind yourself with what is always referred as counterclockwise circulation in northern hemisphere. So a funnel cloud in stage 1 tends to touch the ground if the ground conditions are favorable. This generates mature stage, and this mature stage is where you have got large amount of condensed particles, which creates a low pressure funnel, having the capacity of sucking everything which is there. So this sucking motion that develops within tornado actually makes it destructive. And then the cloud motion as shown in this figure, stage number 4, shrinking stage, and then it decays. Decays is that it ropes out, moisture content is dying out, so it loses the ground contact eventually. So how exactly a tornado develops? Tornado develops when there is the cloud formation. Understand it with this figure. There is the development of a cumulonimbus cloud with its anvil top and the shooting top. If the surface is warm and has generated the circulatory motion of the air, which is facilitating the movement of the moist air, then the cloud funnel, then there will be the development of the cloud funnel, and once this cloud funnel touches the ground, it develops, which is part and parcel of a defined mesocyclone. Tornado has capacity of sucking everything because it is a low pressure funnel. See the stages one more time. Funnel cloud touches the ground. Intense low pressure funnel, destructive. And then it starts dying. The developed types of tornadoes includes land sprout, which we have already learned. This is our funnel. This is our cumulonimbus cloud. Diameter of this type of tornado exceeds its height. Multiple vortex, I can have this tornado here. This is a bigger tornado developed on ground. And a waterspout, which is the most common type. What is waterspout tornado? See this with this diagram. Tornado developed on water surface, tornado developed on land, and tornado which can develop both over land and water, however has got more than one funnel cloud developing. That is how we demarcate types of tornado. If in warm water there is the development of strong wind and it's rising, light wind helps the spin updraft forming cumulus cloud. So the spin have started because it is a warm air, and it has started developing the cumulus cloud. I can see the cumulus cloud here. The surface winds, we have taken the step number 3 first. The rotation begins as the warm air converges on the column of rising air, and this results into a dark spot on the water as the first sight of waterspout, and then there will be the development of this cumulonimbus cloud. It is much easier for us to visualize water out to be nothing but water pillar. That is the suction capacity of a tornado that tends to suck out the water as it develops on the water surface. And don't miss to recall that it will be having counterclockwise circulation. Reading NCERT now. From severe thunderstorms, sometimes spiraling wind descends like a trunk of an elephant with great force, with very low pressure at the center, causing massive destruction on its way. Such phenomena is called tornado. Tornadoes generally occur in mid-latitude, because in mid-latitude will have the development of fronts. The tornado over sea is called waterspout. These violent storms are manifestation of atmosphere adjustment to the varying energy distribution. The potential and the heat energies are converted into kinetic energy in these storms, and the restless atmosphere again returns to the stable state. So, more turbulent the system, is the attempt of re-stabilizing the atmosphere. So, which are the turbulent mechanisms that we talk about? We talk about thunderstorms and we talk about tornadoes. Do remember, thunderstorms are much common. It's cumulonimbus cloud. Tornadoes are comparatively rare. And I want to close this with the reference of this very simple diagram. In climatology, there are few important types of precipitation that we take into account. So, frontal precipitation is what we have insisted today. And if I take the shape of the front, we all can understand that we are essentially talking about which type of front? Here, warm front is visible. Front is where warm air rises only because there is the front which is developed. If the front would not have been there, there would not have been the rising, resulting into the formation of cloud and precipitation. So, frontal rainfall. Which latitude it will be common? It will be common in mid and high latitude. If I experience, horizontal movement of air, experience an orographic barrier, mountain, relief, and it is because of this relief that I am forced to rise, I will be causing precipitation on the windward side. The windward side will be wet and the leeward side subjected to, recall the term, adiabatic warming, will be significantly drier up. We call them rain shadow interiors. So, wetter windward side and drier leeward side. Which type of precipitation it is? It is called relief precipitation or orographic precipitation. And we can also have convectional precipitation, as in warm air is subjected to rise, it is rising on its own and is leading to precipitation. Convectional precipitation can develop thunderstorms. Orographic precipitation can develop thunderstorm. Frontal precipitation can develop thunderstorms with tornadoes. And remember, when I say convectional, I will be dominantly having rainfall. Orographic, I can have rainfall with snow. and frontal, it has to be with snow and then rain and then hail, because thunderstorm, when I say, I am talking about hailstorm. Take the revision. I have not talked about tropical cyclone here. Tropical cyclone have been mentioned in our one of the earlier videos where I talked about Indian tropical cyclones and Kal Baisakhi. If there is a requirement, I can take this again. But I have not talked about this weather system from our NCERT. We have focused on what are air masses, what are frontogenesis related to it, and essentially what are the turbulent weather systems as mentioned in our NCERT as thunderstorms and tornadoes. Don't go beyond NCERT, take support of these diagrams that I have added. I think this is sufficient for us to take our understanding of. Happy learning, all the very best to all of you.